Dear all, now we are going to discuss about differentiation or the topic derivative. Differentiation of what? Or derivative of what? We can say differentiation of a function or derivative of a function. Right. Now I'm going to share the screen. Right. Okay. Shall I take the board? So our topic of discussion is differentiation. Right. So I already told differentiation of what? Differentiation of a function. Let y is equal to f of x. Right. Okay. Or we want to find the derivative of the function y is equal to f of x. It is also called as differential coefficient. That means differential coefficient of what? Of the function f of x. Right. And it is denoted by dy by dx. Right. Or we can say d by dx of the function f of x. I am replacing y by f of x. Right. Okay. So before going to our discussion, I am arbitrarily drawing a function. Right. That this is our axis, x-axis and y-axis. Let this curve will represent a function y is equal to f of x. Now I am choosing a point. Suppose I am using a point here, right? Now I am drawing a tangent at this point. A tangent means that will touch only a single point, right? So this line is the tangent line, right? Tangent line at this point. Okay, so touching only this point. Okay. Right. Not drawing exactly right. Okay. So axis again. Okay. Okay. And this is our right. So I'm using a point here, and with respect to this point, I'm drawing a tangent line. Since this is touching only this point, right? So a tangent touch the curve only at a single point. Now I am measuring this angle. That this is theta. Okay. Then the tangent of this angle, that is tan theta, that is nothing but our derivative, that is dy by dx, right? Or dy by dx is the differential coefficient of the function y is equal to f of x, right? Now I am drawing the same curve or another curve, right? Arbitrarily drawing a curve. Okay, this is a curve. Now I am drawing a secant, right? Because this line is a secant, right? Why it is called secant? This will cut the curve at 2 points. This will cut a curve here and at this point also. Now I am applying a uniform force here. I am applying a uniform force here, pushing this line. So what happens? This will move to this point. Then this line will move to this point, and finally this will touch only a single point, right? Single point here, right? A single point. Now this line will represent a tangent, right? So this is equal to theta, and tan theta, that is our derivative, that is dy by ds. So we can say tangent. What is a tangent? Tangent is nothing but the limiting case of a secant. So tangent is nothing but it is the limiting case of secant. A secant will cut more than 1 point, right? Secant. Here it is 2 points. We cut the 2 points, right? So this is a derivative, right? We will discuss this in detail by explaining the classical method of differentiation or classical method of derivative. before going to this, we can discuss our ab initio method. Ab initio method. This method is also called first principle of derivative. First principle of derivative, right? Okay. So I will explain the things in a very simple manner. Then we can increase our level or standard of explanation. Suppose let I have a function y is equal to f of x, right? So look at this curve, all this curve, right? What I drawn is continuous curve. Previously, I drawn this curve, right? This curve is a continuous curve. This is also a continuous curve. So suppose we have some interval. Here it is a, here it is b. So the function is said to be differentiable or derivative exists only if the function is continuous in an interval, right? So if suppose the function is continuous in some interval a to b, then only the function should be differentiable, right? If there is some discontinuity at any point in between this closed interval a and b, then the function will not be differentiable at that point. That etc. we will explain in detail. So we are assuming the function y is equal to f of x is a continuous function in certain interval, right? Now what I am going to do is I am increasing the value of x. Suppose x is input and y is our output variable, right? X is also called the domain of the function. The value of x is called domain, and y is that's the range of the function, right? Suppose the input we are increasing x to x plus delta x. Delta x. Here what is delta x? Delta x is nothing, but it's very minute change. Minute change. Minute means a small change, right? Minute change. Okay, or a small or very small. That is not small, very, very small change in the variable x, in the value of x, right? Okay. So what I'm going to do is I'm making a very minute change in the value of x. So obviously there should be a small change in y. Due to this change, let the value of y is changed to y plus delta y, right? So delta y represents a very minute or a very small change in the output variable, right? So we can represent this condition. How? What is y plus delta y? I'm writing y plus delta y. This delta y results due to a small or very minute change in the input variable. So we can say this is equal to f of x plus delta x, right? Now let this is equation number 1 and this is equation number 2, right? Okay, we'll explain this all by drawing the graph right later. Now what I'm going to do is I'm subtracting 2 and 1. So 2 minus 1. What does that indicate? 2 minus 1 means this y and y get cancelled. So the remaining is only delta y. So delta y, that is equal to f of x plus delta x minus f of x. Right. Now, the third step, what I am going to do is divide LHS and RHS by delta x, right? So we can divide LHS by delta x, right? So delta y by delta x. This is a ratio, right? Now, if we divide LHS, we should divide RHS also. Otherwise, the equation should not be get balanced. Minus f of x, this divided by delta x, right? I already told delta is a very, very small change. Very small change that it tends to 0, right? That is, suppose that is negligible. So I am applying the limit. That is limit delta x that tends to 0 del y by del x. This is equal to, I am applying limit in RHS also. Delta x tends to 0. F of x plus delta x minus f of x whole divided by delta x, right? This is nothing. This is the derivative. So this term, that is limit delta x tends to 0, del y by del x. I am repeating, that is a ratio. That is called derivative or differential quotient of y with respect to x. So I can replace this term by dy by dx. Right, that is equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Right. By using this, we can find the derivative or differential coefficient of any continuous function. Right. Okay. Now, actually, what this represents, we told dy by dx. That is equal to limit delta x tends to 0, delta y by delta x, right? This is a ratio. Delta y by delta x is a ratio. Okay, but this quantity is not a ratio. It's not a ratio, right? This is not a ratio. Right. Okay. Now, this is also denoted by d by dx of the function. Okay, actually, this is that I told, that is not a ratio. We can also denote this by d1 by y. d1 is d by dx of this y, right? So d1 stands for first derivative. Suppose I am writing d2, that is second derivative, d3 third derivative. This we will discuss in detail in the later sections, right? Or we can say, right, d1, that is equal to d by dx, right? So this is not a ratio, so don't misunderstand. But this thing, delta y by delta x, that is a ratio, right? Okay. Now, suppose we set, what is this is delta y delta x by y by delta x, or limit delta x tends to 0. I am again writing dy by dx, right? This is nothing but this is the rate of change in what? Rate of change in y, in the variable y with respect to x, right? So derivative or differential coefficient is nothing. That is the rate of change in the output variable y with respect to x. Okay, suppose somebody is writing dx by dy, right? Dx by dy. What does that indicate? That indicates nothing. The rate of change in the variable x with respect to the variable y. So, as per the classical definition or ab initio method or first principle of differentiation, we can write this as limit del y tends to 0. Then it comes the ratio delta x by delta y, right? This we can write as limit delta y tends to 0, 1 divided by delta y by delta x, right? Now what is this? We can take the limit in the denominator, or we can write this is equal to 1 by limit delta y tends to 0, delta y by delta x. This is nothing but dy by dx. So we can write this is equal to 1 divided by dy by dx, right? Okay. So we derived or arrived in another proof, that is derivative of x with respect to y. That is nothing but 1 divided by dy by dx, right? Okay. But what about the second derivative? Second derivative means, right, we can write d square y by dx. This is a second derivative. Okay. There's no need to, I am just simply saying about second derivative. Okay. Second derivative means if we have first derivative given, we differentiating again the first derivative, then we will get the second derivative. We again differentiating the second derivative, we will get the third derivative, and so on. So this is not equal to 1 by d square x by dy square, right? This is not equal. Okay. Then what is the value of second derivative? That we can find. We can write d square y by dx square. That is equal to d by dx of what? Of the first derivative. Derivative is dy by dx. Okay. This is correct. Right. So this is wrong. And we can say this is right. Okay. Now we can do a simple problem based on ab initio method. All right. And the sir? Sir. Sir, അതെ രാമനാഥ് അവൻ 112A സാറ് അതിന് തൊട്ടപ്പുറത്ത് തോന്നുന്നു 112A. ഓക്കെ ശരി സാർ. Sorry, I just hold him. Right? Sorry. Okay. Now based on this, we can do one problem. Suppose I am writing y is equal to sin x. I want to find the derivative of this function. I am putting this equal to 1. Now we can make a small change in the input variable x. This is our input variable. I'm going to make a change, small change. That is x plus delta x. So the corresponding change in y, that may be denoted by y plus delta y, right? So this is happening due to a small variation or a minute change in the input variable delta x. So I am writing this condition as y plus delta y, that is equal to sin of x plus delta x, right? Now we derive two equations, right? Now what I am going to do, previously we just subtract equation 2 and equation 1. Similarly, I am going to subtract 2 and 1. So 2 minus 1, that will result in delta y, that is equal to sin of x plus the delta x minus sin x. All right. Now we are dividing this by delta x. So LHS and RHS is divided by delta x. Now what is the next step? Next step is simple. We simply just apply the limit. Now limit delta x tends to 0. Del y by del x. This is nothing our derivative. That is dy by dx. So we need to apply the limit at RHS also. Limit delta x tends to 0. Sin of x plus delta x minus sin x. This whole divided by delta x, right? Now this is in the form sin A minus sin. Sin A minus sin B. What's the result? We can write this is equal to 2 times cos A plus B by 2 multiplied by sin A minus B by 2. Right? It's a well-known identity. Sin A minus. So by using this identity, we can simplify. Right? So we can write this as limit delta x tends to 0, 2 times cos, right? Cos of x plus delta x. That means x plus delta x by 2 multiplied by sin del x by 2. Right? X and x cancel. All divided by delta x. Now I am going to make a small manipulation, small mathematical manipulation. That is limit delta x tends to 0. Cos s plus delta x divided by 2 multiplied by sin delta x by 2 divided by delta x. We can take this 2. Here is 1 2. That 2 is taken into the denominator. So we can write this as in this form. So here this 2. This 2 is taken to the denominator. Right? So I am okay. This right. Okay. Now what is this quantity? This is a well-known limit. Right? So we can apply the limit. Now by applying the limit, we can write cos x plus del x is 0. So 0 by 2 that becomes 0. Right? Cos x plus 0 by 2 multiplied by limit del x, right, tends to 0, sin del x by 2 divided by del x by 2, right? If del x, suppose del x tends to 0 means del x by 2 also tends to 0. So I can simply write a 2 here, right? If this is tends to 0, obviously del x by 2 tends to 0. So I wrote this thing. So this is a well-known limit. What is the value of this limit? Value of this limit is 1. We can know that limit x tends to 0, sin x by x. This is equal to 1. So comparing with the standard result, the value of this is equal to 1. So we can write this is equal to cos x, right? So cos x, that means dy by dx is equal to cos x. Here what is y? That is d by dx of sin x, right? That is equal to cos x. Okay, it's a well-known result. So this is the first principle or fundamental principle of derivative for ab initio method. By using this principle, we can find almost every standard results, right? We can do one more problem. Suppose we have function f of x or y is equal to an exponential function e raised to x. Okay. Now what I'm going to do is I'm going to make a small variation in the input variable. So the corresponding variation in the output variable is delta y. That is equal to e raised to x plus delta x, right? Okay. Now let this is equation number 1 and this is equation number 2. Now 2 minus 1. What is 2 minus 1? We can write as this become y and y get cancelled. So delta y, right? Delta y that is equal to e raised to x plus delta x minus e raised to x. Okay. Now divided by delta x. Here also divided by delta x. Now apply the limit. Limit delta x tends to 0. Here also apply the limit delta x tends to, right. So this is equal to limit delta x tends to 0. We can take e raised to x common. So e raised to x multiplied by e raised to delta x minus 1 divided by delta x. Right. This is a standard limit. This limit is a standard limit whose value is equal to 1. Since by using this result, limit x tends to 0, e raised to x minus 1 by x. That is equal to 1. Right. Okay. Here limit is delta x. So the exponential power is delta x. The denominator is also delta x. So the value of this is equal to 1. This term is independent of delta x. So this is equal to 0. So we can say the derivative of e raised to x with respect to x, that is nothing, e raised to x itself, right? Okay. Now we can do one more problem. Let y is equal to square root of x, right? So similarly, I am making a small change in x. The corresponding change in y is delta y. So we can write this equal to x plus delta x. Equation number 1 and equation number 2. Now 2 minus 1, that implies delta y, that is equal to square root of x plus delta x minus square root of x, right? Divide by delta x. Here also divide by delta x. Now apply the limit, right? So we can write this as limit delta x that tends to 0. Delta y by delta x. This is nothing but our derivative dy by dx. Okay. So we have to apply the limit in RHS also. That is limit delta x tends to 0. Square root of x plus delta x minus square root of x divided by delta x. Okay. Now I am going to do a simple mathematical manipulation. I am going to multiply this factor by square root of x plus delta x plus square root of x, right? So first balance the equation. I have to divide the denominator by the same factor or same thing. So I can write this is x plus delta x plus. Now the equation is balanced, right? Now multiply these two terms in the numerator, right? So what we will get? We will get limit delta x tends to 0. This time become x plus delta x minus x all divided by delta x multiplied by square root of x plus delta x plus square root of x. Right. Okay. Now this x and x gets cancelled. So the remaining bit, there is only delta x, right? By cancelling this, we can rub it. Right? Okay. Cancel. Now here delta x and delta x is cancelled. Now apply the limit. What is the remaining terms? Remaining terms, 1 divided by square root of x plus delta x plus square root of x. Applying the limit, this term becomes 0. So the remaining become 1 divided by root x plus root x. That is 1 by 2 root x. This is our result. Right. So by using this method or this principle, we can find the derivative of some of the most common function. That is our standard function, right? Then we have various methods. Okay, various methods and various properties that we will discuss in the next session. Okay, thank you.